many of you know the speaker, but for example, Joshua was not there when Tatiana was part of the lab. And Tatiana is an engineer, and she's currently doing studies in sociology of science and techniques. She worked with us on her project that she will present today, and actually she made an installation on the rooftop. You know, the rooftop near Montparnasse, and yes. So I will let her present her further and tell us about her project.
Thank you, David. And well, first of all, I'm very happy to be here because it's like not often that I have the opportunity to present what I do in terms of research and not in terms of business. So it's both like very exciting and kind of stressful. So bear with me. So this is what I usually first show on my presentations is basically what I want to do is have these walls in the streets that go from this to this. And how do we do this? And I'm gonna introduce you into what I do, of course, but most of all the mythology and how I do things, how I view things, how I get there, and how I think about my engineering problems. Because I think that's the most important and interesting thing about what I do. And so Vertil is the business that I'm kind of launching, and it's about urban vegetation and how to make social connection through urban vegetation mostly. This is the team, the original team with which we are working, which is composed of me, Marilou, which is a design student at ENS de Saclay, and Ludovic Saint-Bezel, which is a professor in robotics at ISIR, the laboratory at Sorbonne University right there. And so to give a bit more background into how I get into things and why I do something very interdisciplinary, it's because I have a very interdisciplinary background. So it started at Université PSL, right there, in the Bachelor of Arts and Sciences, where it like really set all the first roots of interdisciplinary research for me, which was very, very important. Then I did an engineering degree where I also double majored in environmental sciences and electrical engineering because I really wanted to do robotics, but it's not eco-friendly at all. So that's how the project began. I wanted to specialize into both those things, and working on urban vegetation allowed me to, mix the two. And so I had to negotiate with the school to do this kind of double major, and that's where we were at. Then I did a gap year where I did a bachelor's degree in design, which helped me not only bring the functional aspect of things in terms of engineering, but also how we interact with things, how we design things. What design is mostly the same thing as engineering, which is solve a problem, but with other methods. And so I was very happy to, begin to have integrated these methods in what I do. Then last year, I finished my degree at École Polytechnique in a master's degree in robotics. And now I'm kind of doing an in-between. I'm studying STS, which is Science and Technology Studies, so mostly sociology of science and techniques, which was later in the goal of merging sociology and mechatronics in the PhD plan. But here, it's just to show you that I'm trying to navigate between very different things, but that have all the same goal, which is how to make cool objects that make sense, mostly. And yeah, no, it was not to show off. It was just to explain like where I navigate in this world, which is kind of weird and hard for me. And the first thing I want to introduce you about is what I trying to call intelligent mechanics, and the fact that I'm really trying to think about the systems into how do I put the most of the intelligence of my system in the mechanics and not in the electronics and not in the code and not in the informatics behind. And so there is like almost non electronics in what I do, and it is wanted. It's a goal. I'm looking to go towards that. And to explain this kind of concept, which is not really a concept, but something that is like, forming in my minds and other minds also, I want to talk about Marley's machine. Maybe you know about it. It's something that I find really amazing. It's a machine that was built in the 1680s, so more than 350 years ago, before even we had pumps. And it's a machine that was made so that Louis XIV, in his Chateau de Versailles, could have fountains of water that were functioning at the same pace that he was going up the hill with his whole court. And at the time, there was no pump. And so this machine was made so that it works solely on the first force of the current of the Seine, which is pretty amazing because it's like a huge thing. It was working only with the Seine and pumps and things rolling over and the weight of gravity, and that's how it made the water go uphill. Because the problem is that the Chateau de Versailles is really uphill, like there is like more than 100 meters to go up, and so I think why I want to talk about this machine first is because I think it's very inspiring that at some point in history we really wanted to make things very impressive without the need for thermal machines, without the need for, well, we didn't have electricity back then, but not even a vapor machine or anything. And I think that's very powerful, and that's, I think, something we should look at like where we can go. Like if we can do this, maybe we can do other stuff that we don't want to do this way today. And so that's why I'm trying to formulate as intelligent mechanics is making mechanics intelligent or social in the way that it's made for people and by people and not as something external from people. And to put the intelligence of the system in the mechanics or the mechanisms rather than in the code or the electronics. That way, it's also less materials, less electronics, and so less things that are extracted from the ground. It's also more robust and sustainable in terms of it takes some often less maintenance and none or almost no energy consumption. So that's kind of in a paradigm of speaking of robustness versus performance, which is, maybe you have read Olivier Hamon, which is a big thinker in this kind of movement, is how to shift our perspective in how we evaluate things. Today we evaluate the performance of things, like we want something that does something really good in a very precise manner, and something robust is something that will be able to handle very different specifications, very different tasks, very different situations. And that's something I want to go forward to. And so that's why I'm trying to work out in how I do things. So this is really in the low tech movement of low tech is not low technology. It's not low like no tech. It's not low scientific. It's not low. It's not. It can be low tech is also very interesting in terms of scientifically challenging. The low tech today is defined as something that must be useful, accessible, and sustainable. Useful in terms of it solves a problem for real. Accessible in terms of both, it can be accessible to people to maintain their own machines, or accessible in terms of materials that we can find easily, and sustainable in terms of it has to last for quite a time. and so it's not going back to the old days. It's really how we can make very smart stuff with the things that we've learned in terms of physics, in terms of everything, with what we have, and not with things that are so deep underground that we have to kill people with. Before I go further, I know that this is a kind of a politically engaged presentation, and it is also the goal, because well, technology is not neutral. It's everything but neutral, and I believe it's my work as a researcher or people that do things to not only position myself in terms of this is the technology that I'm using, and it's from this kind of papers, and I'm in this field of research that we basically do as researchers. Like, this is where I'm from, but it's also this is why I do things and how I want to do things and for whom I want to do things. And it is politically engaged in accepting this as what I do being a choice and not only just technology going forward, has helped me a lot into how I want to make things and what are the limits that I put myself to really stay in this focus and not deviate into the more technological things. And we're going to see that sometimes I could have done much more easily things with just putting some magnets and stuff. But that's not why I want to do this, and that's not the line that I've put myself into. So that's something I won't do, which makes things harder, but also much more interesting for me. So vertil, which is so urban vegetation. The problems that I'm tackling is urban heat island effect, which is the difference of temperature between the center of the city and out of the city. So, for example, Paris is like one of the worst in Europe. It's like 6.4 degrees mean temperature between the center of Paris and the outer layer of Paris, which is why when it was snowing, for example, it lasted a few days outside of Paris, but not in Paris. And it's also the lack of social connection that I'm trying to tackle, which is that people feel more and more lonely, which is a real thing in the Western world, I guess. And it has become since 2023 a real social health problem. So that's what I'm trying to mix into two problems into one solution, and that is, well, basically that's what is happening right now. And we're trying to focus on urban vegetation, which allows us tons of things, which is not only cooling effects, but biodiversity protection, air quality improvements, improvement of well-being for people in cities and everything. And how do we do this? Basically, we're trying to do vertical shared gardens, which means that I'm trying to build walls that where plants can move. So if I want to take this flower pot that's down there, I just have to activate some handle, and then it just goes back down, and I can put it back up. And this way, we can really have more than just decoration. We have something that can be shared, that can be an activity, that can grow stuff. Also on the vertical part of the city, which has not been used for a while. We have just mostly gray walls. And so that's what I'm trying to build for the past 3.5 years. There's tons of people in the urban vegetation thing, and that's mostly what I see. It's like, if it's vertical, it's mostly decorative, and if it's horizontal, then we're gonna be on the roof and not using the vertical space. So I'm taking you back because if lots of you know what I do, maybe lots of you have not seen the first things and how it came around. So I'm taking you back to the first small scale prototype that was a really long time ago. And the goal was to do something that was just moving up and down this way, just mechanically. And so we arrived with a system of self-blocking where we just used the weight of the plants, so that when the weight was when it was not moving, the weight is pulling this part here down, and it gets inclined and it blocks the system so that nothing moves. And when we wanted to move, there's like something just behind it that was putting it back on the vertical, and then we could move it up or down however we wanted. That was the first thing that was kind of in thoughts around there. And but the problem with it is it could just move up or down, but it really did not solve the problem of getting something from up down there and then putting back up. And so then that was the first year where I started working in the back of the lab at Easier in the underground. And then I arrived at Sony 2 years ago, 3 years ago, 2 years ago, where we changed the prototype entirely because we wanted to do a true scale prototype, and for it to work, you've seen the first prototype was moving this way if the wall is here, and it did not really work. So in order to make it a true scale, we turned it 90 degrees, and so we could see the thing moving that way. And that's a way we can have a counterweight between the two sides. It's very easy to do. We do not even need a motor or anything. We can just use a hand crank. And that works really well. And so that's what we did. But we really wanted to use recycled materials. So here you have the first experimentation with bike chains, which were not solid or big enough for the use that we had. So we had to come up with bigger chains with tiny handles so that we can put that stuff on there. Lots of friends that came around to help with the first thing, and it started taking form until it arrived like this at the integration where Peter was. Well, today it's not looking like this anymore. The problem that we had with this, so it was a first step at being like, we can do this for real in the big step, in the bigger scale. But the problems that we have is that the mechanics was like really not good. We didn't have anything. We had to pull directly on the plants so that we can make the whole system turn. And the real problem is getting the flower plants to stay on the same orientation through the whole movement, which is like for this first thing, there was just one pivot that would do the thing, and since it's really vertical, the weight would basically keep the thing vertical. But if we want to have bigger flower pots, we have to keep the thing straight, and that was the whole goal of the second prototype. Yeah, not very impressive. Third last prototype of how we keep these things straight, the whole thing. And so that was, so again, I could have just put some magnets, some sensors, and just have a motor that just do the rotation when it feels that it's turning. We could have done that, but where's the fun? So we designed a device that is doing the intermediary between the chain that is tracting and between the flower pot. And so those tiny wooden bricks that we'll call modules are here for that. They're in a big metal guide, and the whole goal of these things is to stay vertical on the whole way, and that way we can have things that stay straight the whole time. So that was the goal. Here's how it looks it's a pretty complicated piece because so we had tons of wheels so that it stays vertical and it moves smoothly and everything, and so that it pivots smoothly also. And we had to find new ways to be able to fix everything on the chains and on the structure so that it can stay adjustable, because what we have found during those months on the roof is that for something that is 3 meters height, we are at 1 millimeter where it works or not works. And so everything has to be adjustable so that we can really have very thin and very precise way of making things move. And so we had to come up with new things to help the movements and everything being smoothly. And we still had to find this thing of like the system moves, right? Perfect, but 90% of the time it doesn't move, it stays the same. And so we have to find something secure so that it does not move when we don't want to. Again, we could have done this in a very easy electronic way, but where's the fun in that? So we made a self-blocking system like this, so that when it moves, these parts are vertical and it does not, the modules can move around freely. And when we turn it on the other side, on the horizontal, it blocks the modules and nothing can move. And this is very secure, it does not move. And lastly, we had to figure out, so this is kind of Mayan's work and internship last summer. I also had the problem of watering the thing. So yeah, you have plants and you have to water them, and you don't necessarily want to put everything back down to water them one by one. So we have to figure out a watering system that is autonomous. But how do you water something with things that move? And how do you have this fixed watering system? And once again, we could have done an automatic watering system that already exists, of course, but where's the fun in that? So Mayan has worked on a watering cans that are connected to one another so that we can arrange them by columns, and so that we can just have to pull on one string so that it all activates and directly water the different flower pots at the space they're supposed to be. And this is the last results, last pictures. I was scared of putting a video because the problem that we've had lastly is that, so basically it works. It works fine. And when we put the pots with water in them, the weight is just too big and the friction is too big, and so it derails or it does not move or so many things. So I think what we've learned from this version is that we, first of all, straight 90 degrees angle, not a good idea. And then we've been, I think, where we could go with those technical choices, like the chain, for example, and we've pushed it as much as we could. But now we have to go, I think, in another technical direction, and that's are going to be the next steps of making something better. And so we're going to go back to the small scale, to some more prototypes in the small scale to validate really one mechanism before going big scale again. So yeah, that was about everything we've done for the past 3 years for these walls. And I'm just gonna open into what are the next steps for me for Vertil, for me as a student, researcher, entrepreneur, I don't know, and what is going to happen. So Vertil has been tons of other things recently, because I really wanted to go back at the core of why do I do this all the time. And it's just not green walls, it's how to put back social connection and creativity through ecology and urban vegetation. And so we've started to do some workshops and creative workshops with kids, with adults, into how to talk about the environment in a creative way. And we've started to make some games with seed bombs so that we can have some kind of Pokemon cards for seed bombs and bring back joy and games into the thing of planting and everything. And so Vertil is going to do that thing. We're also trying to make some new shutters so that we can go on a vertical level also where there's lots of windows, like right there, to fill the blanks in the walls with green stuff. And for me, it's kind of in working by now. So have you seen? I've done tons of very different studies, and I'm trying to put this all together into a PhD where I want to study, well, in between mechatronics and sociology of techniques, on how what are the values carried by the objects that we conceive? How does, for example, the specifications documents or the requirement documents that are all the documents that we need to make projects, whatever they are, how do these documents are taking values with them, and how is our work not natural, and how to create tools, because all the time, of course, I'm saying everything is not neutral and we have to think about it, but we as scientists and engineers are not trained for this, we're not educated for this, and how to think our own practice in terms of social interactions, in terms of interactions between technology and society and people, and everything is very complicated, and it's like not something that we're used to. And there's, on the other end, some sociologists that really just are here to study us, and that's very interesting, but it's also not helping us to put on some tools to how to bridge the two. And so I'm trying to, I don't know, I guess, do that. And so that's what I'm working on right now. Yeah. So thank you, everyone. And if you have some questions, don't hesitate.
Thank you. Thank you, Tatiana. I have some questions.
Yeah.
Could you go back on the blocking system?
Do it?
The slide talking about the blocking system.
Yeah.
I do not really understand how it works.
Yeah. So there's the whole thing is that central piece right there is gonna push those planks where it has forks. Okay, and those forks. So the planks are level, and they cannot move only horizontally. And those forks are going to welcome this piece that is what is carrying the module, okay, which is carrying the flower pot. And so if this piece is not moving, the chain is not moving, nothing moves. And so I think those forks are going to just block every module, so the whole chain, so nothing moves.
And
yeah,
when does the central piece, when does it move?
Like you have to activate it by hand. Like there you have a metal stick that you can just activate it by hand.
But so they need to be facing the exact location where the metal stems.
Exactly. So yeah, the modules have to be in the right location, and so there is like some there's a visual guidance to align so that it's on the right spot. Yeah.
Thanks a lot for the presentation. And for the third prototype, so you listed the things that fail.
Yep.
But is there not a space of plants or installation that makes sense to still push it? Like, for example, if you had moss panels instead of flower pots, then you wouldn't have too much water even when it rains. And so it's like there is so much work in it. Is there not a way to exploit it?
So of course you can exploit it with tiny things, and it's going to work, but it's not sufficient for what I want to do with it. In terms of on the long term, I want to have a structure that is solid enough so that you can put both moss panels and flower pots and everything, and it has to be resistant, robust. Yeah. So it cannot be just performant for one tiny thing. It has to be like I can interchange different types of things with different weights, and it still has to work. Yeah. And so for this, I think we've come far enough, and we have had so many problems, mostly with the chain that derails us all the time, that I think really the chain is not the solution on the long run. So we can still use this and push it back a bit more, I think, but it takes a lot of time, and I think that on the long run, it's like not the right solution. Like you can, I don't know, but you can feel when you've done something and it's like causing too much problems for what it should do, and you just change.
Yeah, I see. It's just like it feels like there's still a potential for learning from this prototype to see other cases of failure that you may have not imagined, and you already have something that allows you to push to see where it fails even more in some way.
Yeah, well, I haven't presented everything, but it has failed so much already. And we have worked, actually, I really did not think that we would be able to put, like, we were able to put 9 modules and put 9 things and still moving. I did not think for a long time that we would even be able to put 2. So I'm actually, I don't know. I think we've explored a lot of what it could do, what it could not do, and where were the problems.
But mechanically, yes.
Yeah.
But, and my question is further mechanical problems, like if you install it in several places and see how it goes through time.
Oh yeah. That's a good question, very good question. But you have to move it. Which is
because how long would you say it takes to build?
This one took me, well, if I had to do the same, exactly the same, I think it would take a month.
Okay.
Full time.
So you're not convinced enough by it to make it.
Well, I think it would be very interesting to make the same one again with the same things that I have learned from those mistakes. It's just, it is a lot of time, and there must be the funding and everything to take this time, which I do not have. And I believe right now it's better to really just change the technical thing. But it would be very interesting. I agree.
Okay.
Yeah.
I have a question. Don't get it wrong, but it feels like from the beginning of the project that you're trying to go low tech in a way that's very much bottom up, like starting from the ground up, like where you have not much and trying to build it like piece by piece and go to a solution that makes sense. Do you think there is a way that you could go like top down, like start from a rather high tech solution and try to look at what you can swap in the higher tech solution in order not to have to reinvent the wheel every time?
Yeah, I completely agree.
Okay.
It depends on, like, for the thing is, I have looked for systems that look like this, and I did not really find some. Well, I find some things, but they were never really in the on the same scale. Like either it was for vertical forms, but they do not work the same way. Either it was, I have never find the system that was high tech and I could just low tech for this specific use.
Yeah.
But I completely agree with you. And actually, there's a whole service at l'ADEME, which is the environmental state agency, that does this. Like people come to them and they're like, okay, in your thing, how can we low tech this? And they do actually this, and it's a very nice process that they use. And that's also something that I spontaneously do when I talk with other entrepreneurs that are doing very high tech stuff. And I'm like, okay, do you really need this? And can you just swap like this from this? And that's something that I trying to use on an everyday basis. For this specific thing, I have not found what I wanted. And it's also because at first this project was for me to learn to do mechanics. So I wanted to have to reinvent the wheel because that's what I was looking for at the beginning. I just wanted to be able to build stuff. And so you never understand them better than when you make it yourself.
That makes sense.
And well, now it's become something much more, but at the beginning was this. And so then we've been on incremental research, and I still believe it's like going somewhere.
Cool. Yeah, thanks.
I have a question.
Yeah.
It seems from what you said, like code and computing cannot be part of low tech. So
yes, it can.
It can. So in what way?
Okay, so low tech is not. There's not some things that are low tech by nature. Low tech is always relative to something. So it's like a process. So you're going towards something. L'ADEME talks about une démarche, like low tech. It's like not something is low tech by itself. It's always relative. So there's lots of experimentations and more than experimentations today about like le numérique sobre ou responsable, which is how to, like for example, AIs that are not specifically large models, but very specific models trained on very specific things so that they don't have to be huge and take so much data and so much energy and stuff like this. And this is low-teching, I guess, informatics. And I think that's very interesting, but it's also, it depends on the use that you have. And for example, one of the things I want to pursue is to build a sensors network to be able to evaluate vegetation's impacts in the urban area, because that's something we don't have any data on. And how to do that is like really I want to go with very low conception sensors and how to get only the data we need and not the whole data thing that we don't necessarily need to have something interesting to say about it. And so I guess like low-teching information is about using the data that you need for the use that you need and not necessarily going always more sophisticated, I guess.
If I can follow up on David's question, then if low to high tech is kind of a spectrum and low tech is rather the trend of going towards as low technology as possible, where do you set your threshold? What do you decide is low tech enough for you? Is this something very personal attached to some kind of almost a feeling, or does it need to be backed up by some data, like the ratio of energy you consume with respect to, what is it that makes it low tech enough?
It's a very, very good question. I've always think I understood low tech as not low technology, but more like I think we have learned so much in terms of maths and physics and material sciences and everything that for me, the goal of low tech is to put all this intelligence into very smart, simple, elegant stuff. It's very difficult to do something simple. That's always something we say. And I think the goal of low tech is to encapsulate in the tiniest way possible, all this is intelligence. And for me, it's what is so challenging about it. And it's not necessarily digging things in the ground, you know, it's much more like how do you take all this knowledge into something that is very simple and elegant, which is very hard. And that's how I view it. And I don't know if there's a threshold, because even I would say I'm not completely low-tech because it's very mechanics and it's like, and it uses some metals and everything. So I would say that what I do is maybe low-tech plus, I don't know. It's more like, it's a process and you're trying to see what makes sense for you and how you could do it. I think it's mostly about asking yourself, how can I do it other ways? Like something else.
Yeah. But here, for example, because what's striking, especially with this picture, you don't have any electricity in the system. Is that a hard no? Like, will you ever consider adding electrical parts to the system, or is it part of your constraints that make it low tech enough?
What I like about the systems that I make is, I think one of the constraints I put myself into is you should have to put maximum 2 motors to have everything functioning.
Okay.
So that it means that the functions, like just with one motor, I can make the whole thing and it moves freely and it stays straight and everything works with just one motor. And that means that everything else has to be mechanically well done. And that's the constraint I put myself into, so that I'm sure that I won't go into something that I find unnecessary. But people can put the constraint wherever they want. But I think that's the thing like nice about it, is this constraint pushes you to go to the maximum of, you don't need electricity to do so many things. And if you did not push that constraint to the maximum, maybe this thing very, very easily done with some electronics and a motor and something that moves like that way, like no problem at all. But when you start to say, is it necessary? Really? For real? And then your brain starts to works differently. That's what I like about it.
Cool, thank you.
Okay. Are there some questions online? It seems no. Okay, so we can close the session and thank again Tatiana. Thank you very much. Bye. Online.